Abeba Birhane is Senior Advisor in AI Accountability and Adjunct Assistant Professor. She is both with Mozilla Foundation and with Trinity College, Dublin. And her flash talk today is called AI for Good, Let Them Eat LLMs.
So I'll be extremely fast, given that I have a few things to say and I have very short amount of time. So before I go ahead and start, just a little warning that some of the data I present contains images that might be unpleasant and offensive. Unfortunately, this is the side effect of working with large-scale data sets that are used as training of large systems currently. So as we've all heard this morning and even after lunch, that we are all been discussing the use of artificial intelligence in the humanitarian space. There are various efforts, for example, big tech, including Microsoft and Google, have dedicated efforts and initiatives, as also we've heard from the panelists themselves, that are working on AI and to adopt these tools in the development space. In academia also, we are seeing a huge increased amount of academic work, again venturing into the use of AI in the social good space. Here are just a couple of examples. Again, this is no news. We have dedicated space and venues that are really working on kind of pushing AI into the humanitarian space. We have, for example, in Geneva, an annual summit that is all about adopting AI for the 17 various SDGs. So before we delve into what AI is and whether it's good or a bad idea to bring AI into these spaces, let's have a very basic understanding of what AI is. Again, I don't have time to delve into it, but at a very basic minimum, various AI tools, or AI as a general concept, is a system that uncovers patterns in a vast amounts of data through optimization process. And because a lot of data that are fed into these systems is historical data, as we are building predictive models, we are kind of recreating a future based on the past or based on what society looks like. And through this process, a lot of assumptions, unverified assumptions, even incorrect assumptions, pass through, slip through. So as we are, moving to implementing AI in the social space, I want to be careful, as I'm going to bring about critical perspectives. If we are talking about, broadly speaking, we can think of AI or the phenomena that we are trying to capture or trying to model or build a model for as a spectrum, moving from like physical systems, biological systems, into the really messy like social systems. So if we are talking about, very basic or very kind of stable systems, such as biological or even physical systems, we've seen excellent examples, particularly, for example, coming out of big companies such as DeepMind, with protein folding, even nowcasting, which is the idea of forecasting the weather for a very short amount of time for the next 2 to 3 hours. Even building models of board games. So AI has proven to be excellent in terms of accuracy, because these phenomena are something that can easily be captured in data, and you can have some kind of general rule that you can optimize, and you can build models with high accuracy and very low ethical considerations or ethical problems or ethical red flags. However, as we move into this spectrum, as we move into the social space, as we are trying to build models that capture social phenomena, the models tend to be extremely inaccurate, and the ethical issues tend to be also extremely grave, so to speak. And just to, again, I don't have time, so I'll just mention a few examples by passing. So we've seen in the Netherlands, for example, where they've used algorithms to aid decision in terms of catching fraudsters, or in terms of the decision of welfare beneficiaries. And there was a huge scandal where hundreds of people were disadvantaged. Some of them even anyway. Also, we've seen in the UK where during COVID, where they've deployed an algorithm to aid decision-making in allocating grades, A-level exams, with an algorithm called Equalifax. Again, after some evaluation, it was clear that the algorithm was allocating grades based on area code as opposed to the merit of the student itself. The decision was reversed. Again, within law enforcement, we are seeing increased examples where these systems make errors, and when these errors happen, the consequences are grave. So far, for example, in the US alone, we are aware of 6 people that have gone to jail due to errors in facial recognition systems. So as we are trying to capture and model the social system, I'll repeat, the models tend to be extremely inaccurate, and the consequences are grave on actual concrete people. So to capture, the more socially complex the thing is, the phenomena is you are trying to model, the less capable and the less accurate your model is, and the more grave the danger is. So also, as we are considering adopting AI for various spaces in development, we have to also remember the fundamental basis that these systems are developed by a handful corporations that are dominating the field, not just only in application, but also in research itself. I'm a researcher, so I will present evidence from the research side. Here, myself and my colleagues analyzed the top 100 most influential machine learning papers from 2 of the most influential venues, which is ICML and NeurIPS. As you can see here, we looked at the affiliations and funding sources for these authors. Back in 2008, 2009, only 11% of the most influential papers were either authored by big corporation authors or had funding from big corporations. But that figure almost grew by 5 times in 2018 and 2019. As you can see, it jumped from 11% to 58%. All this is to demonstrate that the field is not oriented towards justice or fairness, but rather it has a business model that is all about maximizing profits, which is, again, on the opposite end of a lot of concerns that are to do with sustainable development. Sustainable development has to be grounded in values such as justice, fairness, and so on. But that is the way the AI, at least the research as evidence shows, is heading, is on the opposite direction of those values. Also, I will talk a little bit about data, because that is my expertise. As we really are taken by these state-of-the-art generative models, or even just artificial intelligence in general, we tend to forget that it's built on exploited labor, whether it's the data itself, the text, the images, the voices, but also the labor behind it, the data labeling, the content moderation, and so on. And the data itself is borderline illegal. So there are multiple issues, but I'll only mention. So the data itself is sourced in a really problematic way without consent or awareness of data subjects, but also the data itself tends to encode and exacerbate societal stereotypes. And I'll give you a couple of examples from two of my recent works. Actually, this is not recent anymore. This was published in 2021, where we audited an image dataset called 80 million tiny images. We were the first one to actually audit it. Examining your dataset, what's the content of it? Asking these kind of questions is not, unfortunately, a common practice within machine learning. So as you can see here, within 80 million tiny images, this is an academic data set that was used for over 14 years before it was withdrawn following our findings. And there have been hundreds of machine learning papers, specifically computer vision papers, published based on this data set. And on our query, we found thousands and thousands of images labeled with problematic labels, which I have blurred here, and I put asterisks, words such as the N word, the B word, the C word, and so on. And as you can see here, it's the first 25 images labeled with the word N. This is just to show you, to illustrate that data, because the only place you can find huge volumes of data is the World Wide Web through the Common Crawl, and the World Wide Web always reflects, society's problems and ills and nastiness and so on. All data that comes from the web, and most data that is used to train large language models or large generative systems, is sourced from the web, tends to, again, encode and exacerbate societal stereotypes. This is another dataset audit myself and my colleagues conducted recently, called the Line. This one was Line 400 million. It's a multimodal dataset containing image and text pairs. So here, as you can see, this is a screenshot taken from the Lion dataset portal itself. This is the first set of results from the query African, and compare that with European. Again, just to illustrate how these datasets encode and exacerbate societal stereotypes. While the African identity is presented in a very cliched, negative stereotypical way, as you can see, Europe tends to be represented in a very neutral kind of maps and flags way. So necessarily, the problems with dataset always translate to problems with models. If your dataset encodes and exacerbates stereotypes and other problems, your model tends to do the same. And there has been ample evidence coming from both academia and investigative journalism illustrating this. So this is actually just myself playing with DALL-E. The first one is emotional author. So when you type with the query emotional author, you get women kind of looking emotional, whereas the second one is intellectual author, and you get men looking professional. This is stable diffusion. Again, this is my own just little playing around. African people at work, as you can see, the model really exacerbates that really negative stereotype of African people, and compare that with European people. I think the image says it all. This is from NPR, reports that came out in October, where they tried to get Midjourney to generate an image of a black doctor helping white children, and the model simply refused to produce an image, and this is the image it produced. So I'm hoping by presenting all this, you see that the data sets are always problematic, and the models always inherit problems that come from the data sets. And as we are all aware that we are failing behind with the SDGs, some of them were even regressing, and it's natural to look for all kinds of solutions to even go to venture into AI. Here is a report from, here is a snapshot from the SDG Progress Report itself on SDG 1, no poverty. As you can see here, we are really not doing well, and the report itself identifies the root causes as factors that are structural. The same goes for SDG 2, zero hunger. Again, the root cause itself states that things such as, policy solutions, and tackling structural solutions is the best in terms of tackling entrenched inequalities. However, given that, the kind of solutions, the reason why I kind of presented AI as a spectrum or modeling as a spectrum where you can, capture it accurately if you are trying to model a board game or a weather forecast compared to a social phenomena is much of the 17 SDGs squarely fall as a social phenomena that have cultural, historical, and political root causes. So without tackling those, these problems themselves do not lend for a tech solution or an AI solution. So we all wish AI is a magic wand that can solve these problems, but at the end of the day it really is not. So the kind of problems we are looking at are extremely social, that defy complete automation, and the AI tools that we currently have themselves exacerbate all these problems as opposed to tackling them. So the point I'm trying to make is, if we are not careful, by thinking that we can apply AI to tackle SDGs, we might actually be exacerbating. We might actually be just, thinking we are solving the problem, but rather we are exacerbating. So here, this is criticism around, the responsibilities of AI is not new. So Joseph Weizenbaum, who is the creator of the first chatbot, Eliza, back in the 50s, 60s, when he was asked, how can we use computers in schools? How can we use computers in education? His response was that, what is education? What are we trying to solve? If kids are not attending to school because they are going to school empty stomach, if we are just putting a computer in front of themselves, it's easy for us to say, look, we are doing something. We are bringing computer to every student, but we really are not tackling the root cause. We are not even understanding the root cause itself. So just the final point, I know I'm running out of time. Gail earlier made a really excellent point, which I'm going to borrow, that she borrowed from her friend from Nigeria, where she said, if you are not at the table, you are probably the meal. So we are all here sitting in this nice, very nice building in Washington, D.C., contemplating what the problem of the global south or the developing world is, without actually the people that were trying to devise solutions for being present at the table. This is a recipe, again, for disaster, or we will do something that will make us feel good about it without actually tackling the problem. So if we are, again, I'm not entirely against AI or, the use of data itself, even though I'm presenting a very kind of critical view. I have a very nuanced perspective, but the time doesn't allow to delve into that. So if we are actually serious about, tackling inequality, tackling poverty, tackling, structural oppression, and so on, if we really care about the welfare, the interest, and the well-being of, the various communities in the developing world, we have to first understand what the problem is. And this is the kind of problem that needs to be formulated with those in mind, with those at the table. So these are some of the starting questions that we have to base our technological solutions for. What is the history of the problem? What are the root causes? No matter how much data and AI we throw at it, if the root cause is, if the problem needs the political will, it's not, throwing as much AI and compute is not going to do so much. Who is at the table? So I'll leave you with these questions because, and actually here, this is my last slide. Any, successful and effective long-term tech development to tackle, various SDGs has to come from the ground up. It has to be built, it has to be directed, and it has to be it has to actively involve the communities that we are trying to help. And I'll stop at that. Thank you.
Do you want to take some questions?
Yes.
Thank you so much, Abeba. If anyone has any questions, I'd just invite you to come straight up to the mic. Any questions? Lots of thoughts, probably.
Well, you know where to find me if you have questions. So.
Oh, wait, we have one question coming.
Yes, hello, my name is Hartwig, but I work for the World Bank. It's more a concern than a question, but maybe you can answer it as a question. Is the biased results that you showed might also be affected by your browser settings, by the region where you are searching from, by your browsing history or whatever. So what I'm wondering is whether artificial intelligence will also be smarter than we think and will behave towards you like basically social media does as well. They present whatever advertisements seem to fit your profile. So my question is, and I confirm what you found. I am sure it's true what you found. But did you make conditions or did you make provisions to avoid this kind of biases in your findings in this slides you showed? Thank you.
So I'm a dataset auditor and model evaluator. That's my research. So the findings I showed is based on datasets that myself and my colleagues audited. So these are datasets that are compiled by various groups. So the first one was an academic dataset. The second one was academic/industry, Google, OpenAI, and various companies have been using it. This is the Lion dataset. So these are datasets that are kind of assembled and put there as open source, accessible for researchers to build various AI systems for. So what we do is download the data and run various experiments and analysis to see how, certain concepts, values, identities, and so on are represented within those datasets. And unfortunately, we can't audit most current datasets that are used for generative models, like by OpenAI, Microsoft, Google, Meta, and so on, because their datasets are, locked behind closed doors due to proprietary reasons and so on. So what we do is really investigate the datasets that are just out there as open source to be used by academics or tech developers. Because datasets are really core, they are the backbone of AI systems. So a lot of AI now, what really drove the AI revolution over the past 15, 20 years is not, new finding, new equations or new concepts. We've had a lot of the concepts since, the 1970s, 80s, and so on. Jeff Hinton's paper on deep learning itself was back in 1989. But what really gave us the AI revolution is the availability of data, thanks to the internet. As we are exchanging text, as we are uploading our images and so on, that is then harvested and that is used as training material for AI systems. So again, my expertise is to critically analyze what is in these datasets and how are various concepts represented. And to be fair, in order to avoid bias, we try to have, a standard method. For example, if we are querying how the concept African is represented in the dataset, it makes sense to also check how the data fares with the concept European. So that's why we try to present, how concepts are represented in the datasets in a representative way, if that makes sense.
Yeah, I think so. And what I understand is that you did it in a sort of controlled environment, while the majority of us don't work in a controlled environment. So our results may be more influenced by things that we don't know than we think. And maybe even more in the future that the results will be more biased because more parameters are used which are not known to us. And so my results may be different from your results based upon whatever other conditions that I'm using. Thank you.
So if you are talking about how various generative models return, an image or a set of text based on your query, that's a fair point. Depending on how you type, how you frame your query, what kind of words you use, you will get slightly different outputs for similar concepts. So that's a fair point, but that is to do with the models themselves. So the findings I presented is with the data set that's used to train the models, if that makes sense.
Thank you.
I think we have time for one more question. Yeah.
Thank you. I'm Federica Schuh from UNICEF. Thank you for your talk and for your research. It's really important. So my question is a bit, so obviously when we look at some data sets, there's some content in there where it's like, undoubtedly, like it shouldn't be there, right? But then on the other hand, there will never be perfect data, right? And what's a good data set also depends in part what you want to use it for. Because we also don't want to not use data that maybe is not perfect, but it still has really valuable information. And so what's your thought on how to kind of walk that line? And perhaps also, we talked earlier about kind of standards, metadata, ways of also kind of capturing that information about data sets in order to also help people in trying to understand what's a good data set for what purpose, when can you trust it, when can you not? And also one question, when we talk about bias, we implicitly also assume that there is a neutral state, right? And my question is a bit for kind of data sets also, I wonder if that actually exists. And, a lot of your talk is really like, data comes out of messy, complex social realities, right? And I would say is like that neutral state, it probably doesn't exist in the kind of social realities that we have. Right, and so the question is also a little bit when we talk about these data sets and we talk about quality data sets, better data sets for AI training, like what exactly then are we asking for and what are we implying if we talk about the challenge with bias? Thank you.
So I absolutely agree. The idea of a neutral data set is a myth, and we have to really abandon that. It doesn't make sense to think of a neutral data set. And, given data sets are getting larger and larger, so for example, the first data set we audited, I showed here, only contained 80 million images, and then they were labeled with text. But then, they became, thousands and millions and billions. So the latest Lion data set had 5 billion image and text pairs. But now, if you look at training data, they are within trillions of tokens. This is what we hear from companies like Meta, because we don't have access to actually verify the claims. Again, because these data sets are kept a secret. So as data sets are getting larger and larger, it becomes really difficult to check their quality, to make sure that they are, as good as it can be. They are as representative of various concepts as much as possible. So with that in mind, there are so many complexities to making sure that, we have a quality data set. keeping that aside, we don't aspire for a completely fair, neutral, unbiased. The idea of, again, unbiased data set is a total myth. But we can aspire for better data sets. We can aspire for, a more just and fair representative data set. So it's not one or the other. It's not like, biased data or unbiased data or neutral or what's the opposite of neutral data, but rather it's more of, you have to treat it at more of a spectrum. As I said, a lot of data comes from the web, and that is guaranteed unless we go in and, do the quality check. It's guaranteed to be biased. It's guaranteed to encode stereotypes. It's guaranteed to contain a lot of content that shouldn't be there. Bias is not the only problem in data sets. You have like content that is violates privacy. You have content, such as child sexual porn and so on. That just shouldn't be there. So the more we do the due diligence and audits, the more we investigate, the more we detoxify it, the better the data set. So the more we do with the data set, the better it becomes. So we can aspire to do better, even though the idea of, unbiased and neutral are a myth. But that doesn't mean we shouldn't put resources into correcting the data set. Thank you.